Okay, so for this lesson you have a new postulate, postulate 19, which is talking about the side-side-side congruence of triangles. When you have three sides of one triangle congruent to the three sides of a second triangle, then the two triangles themselves are considered congruent. And when you use this as a proof, that's why it's called side, 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 because you have this side, side, another side, side, and the last side. You're going to have some other ones here pretty soon. You're going to have side, angle, side, and is it side, angle, angle? I don't know them all off the top of my head. But this is just the first one you're going to get. So you'll use this to tell whether some two triangles are congruent. So you'd say, yes, they are, side, 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 for the reason, or no, they are not. Okay? So let's look at example 1. All right, so we have this little figure with two triangles, and they tell us, looking at those two triangles, what do we already know? We know that side KL is congruent to which one?
To
NL, right here, see the one red mark?
Oh.
And then we also know that KM is congruent to which one?
NM.
N. Yeah, NM. Okay, because those two lines. And what they're asking you to do with this information is to write a little proof proving that triangle KLM is congruent to triangle NLM. So we know this top part is the given, right?
Mm-hmm.
So these are both given in my little 2-column proof. What do we know about the third side? This one right here. It's the third side of both triangles, right?
Mm-hmm.
What can I say about those?
They're the same.
They're the same. Very good. There's a way to say that they're the same. LM is congruent to LM because they are reflexive. When you hear the word reflexive dealing with triangles, think of a mirror. It reflects itself. So reflexive means it's its own line. You're looking at itself. Okay? Then once we know that's reflexive, we could technically mark this with the third side lines. And then once you have all three marked, you can actually say that triangle KLM is congruent to triangle NLM because of what reason?
Side.
Yep.
Side.
Side postulate. And there's your little mini proof. Not too bad, right?
Yep.
So I want to do a couple of these guided practice down here. Try not to get the answer. All right, so looking at number 1 on the guided practice. Decide whether the congruent statement is true and then explain, which just means give me a reasoning, postulate or no postulate. So looking at the statement right here at the top, triangle DFG is congruent to HJK. Whenever you read it, the first thing you do is make sure that they're written in the same order. DFG, HJK. Okay, good, written in the same order. So automatically you're good to keep going. Would you consider these two to be congruent, two triangles? Yes, why? You say the side, side, side postulate. That's all you have to write for this one. Okay? So let's look at the next one. All right, triangle ACB. So I just tend to draw it ACB, so this triangle, compared to CAD. All right, so they went from the right direction both times. Can we consider these congruent? Well, let's look at the sides. The back side is 7 of both of the triangles. We have the middle line, which is reflexive. What about the base of both of these triangles? They are not the same. So would this, they would not be considered congruent, would they?
No.
And you have to say no, and then when it tells you to explain, you say segment AB is not equal or congruent to segment CD. You can write out not congruent if you don't like the little sign, but the little sign means not congruent. Okay, does that help you understand how to check side, side, side? Good. All right. You will need to have the distance formula. So we've written it probably 5 times in the book so far. So you should have it on an earlier one. But we can write it again. So they give you a coordinate, and they're asking you, which are the coordinates of the vertices of the triangle congruent to this triangle? So they give you an original triangle, and they want to give you another triangle that's congruent to that. So you need the distance formula. Did anybody find it?
I'm looking for it.
Do you remember it yet? Distance formula is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared.
That was the other one we did.
This one. So then you're going to use this formula to find the length of anything that's a diagonal, right? Because we can solve the length of each of these. Here, let me get a red marker. QR, how would I tell you how long that one is? I just count it, right? 1, 2, 3. So the length of this is 3. What about P to Q?
We just counted.
1, 2, 3. That one's 4. So the only one I need to use the distance formula on is my diagonal one. So I need to know the point of P compared to the point of R. So what is P?
P is 5.
-5, comma 4, right?
4.
Positive 4, because I went up. And then R is -1, comma 1, right? So then these are the points I'm going to use in my distance formula. So I'm going to say D equals the square root of, and then it doesn't really matter which ones you use first. So I'm going to say -5 minus a -1 makes that positive, remember? And then y2, you just got to start with the same one. So I have 4 minus 1, and then squared. Okay, now we simplify. -5 plus 1 is what?
4.
-4. 4 minus 1.
4 minus 1 is 3.
Very good. So now what's -4 times -4? Because we're squaring it, right?
16.
16 plus, what's 3 times 3?
9.
9. 16 plus 9 would be?
25.
Which is awesome, because then what is the square root of 25?
This should 5.
That makes sense because of this side length. Eventually, we'll have the lesson where we talk about triplets. You can actually predict side lengths when you have it like this. 3, 4, 5 is a common one for triangles. There's several of them. There's like 10 that you can recognize right away. But now you know how to use the distance formula. Okay, so now we have the side length 5. We need to figure out which of these has side length 3, side length 4, and side length 5. So you can either use the distance formula multiple times, which is a pain, or we can try and see if we can't look at these. So here the x's are the same, right? So that means if I'm looking at a graph, that we're talking about this vertical line, -1 and -1, right? So then 5 and 1 would be the distance of the triangle going up, which is the difference of 4. 5 minus 1 is 4, right? So now we can see that 5 and 5 are the same. So that's the y line, so that's the line going this way. Well, it would actually be up here at the 5. And they have a distance of what? How many spaces between -1 and -4? 3 spaces, right? To get from -1 to -4, we go 3 spaces. So then maybe we should look at A and see if we can use the distance formula to find the last part of this. So we need to find the distance between 1 and 1 and 4 and 5. So I'm going to turn the page here because I'm out of space. So we're finding the distance between -1, comma 1, and what was the other point? -4 and comma 5. So use the distance formula. Distance equals, and this is x squared minus x1, so -4 minus a -1 squared, and then y2 is 5 minus 1 squared. So -4 plus 1 would be -3. 5 minus 1 is 4. What's -3 squared? 3 times 3 is 9. And then 4 squared would be 16. What's 9 minus 16?
9 minus 16 is 7.
I did something wrong here. Oh, this is a plus sign. I was like, something's not right. So 16 plus 9 is, all right, we found it on the first try. That never happens. So the answer to this one is A. Sometimes you may have to do several of those to find the right answer. Hopefully they're not going to make you do multiple choice. They'll just ask you, what's the distance of the third line? Because then it's less work. Okay, so I would again write the distance formula in your journal so you have it. All right, look at example 3. That's 3. All right, so we have a picture at a football game, and we have 2 benches. We have one bench that has a diagonal support beam, or the second one that doesn't have any support beam. Explain why the bench with the diagonal support is stable, while the one on the right that has no support might collapse. What do you think? Somebody tell me why they think this diagonal one would be more stable. In your own words, doesn't have to be mathematical.
Because it has the thing in the middle supporting.
What does this support beam specifically do you think?
It reinforces it.
Reinforces it. That's a good way to say that. What could happen to this bench without that support beam? How would it fall, do you think? If I have two lines like this with a bench on top, and I have two very large gentlemen sit on it, if they sit down straight, slowly, it'll be fine. But if they shift at all, what's going to happen to these? They're going to lean. So the bench is going to kind of topple to the right or the left, isn't it? It's going to fall sideways. With this one right here, well, what is the reason it might not fall sideways? Holding, that's the word I was looking for. It is making it a fixed point. This point and this point are fixed. They're nailed in, they're screwed in, however they made the bench. To make this triangle sitting on top of this triangle, that causes these 2 points to be rigid or fixed. So they can't shift to the left or right. Now, if the screws wear out, it'll still fall over, but this is what creates fixed side lengths that can't shift at all. Does that help? So now we're going to look at some pictures of figures and decide whether they're stable or not. Don't look up here because you might see the answers. Because I can't seem to take pictures without y'all seeing the answers first. So just give me a second to crop it out. All right, so we have 3 photos here. You're going to determine whether the figure is stable, and then tell me why. So looking at the very first figure, would you consider this stable? The square?
No.
No, why?
Because it can still shift.
It does not have the
Fixed point.
diagonal, support. Does not have. I would put this in your journals. Just sketch them real quick. They don't have to be perfect. Diagonal support. Okay, what about the second one, number 6? Would this be a stable figure?
Yeah, it has the diagonal support.
Yeah, it is stable. It's funky. But these are fixed triangles. They're not going to move, are they? So, yes, has the support. Okay, what about number 7?
No.
Why no?
It doesn't have a diagonal support.
It has this support, making a triangle, but what's that second shape?
It's like a rhombus.
Yeah, it's a quadrilateral that could shift. Basically, this point's not fixed, so this is the weak point. That's going to be where it shifts incorrectly. So no, the lower half doesn't have support. Has no support. Okay, this is in your assignment, some of this stuff, so this will be able to make it easy to knock it out. All right, any questions?
No.
Side is what creates stable triangles, fixed points, and you can prove things. Number 1 through 7, and then 9 through 15. It's actually a really quick lesson. I bet you guys can get it done.